All right, welcome to Unit 5, Ratios, Rates, and Proportions. Go ahead and fill out your date, and we're doing Learning Goal 38 and 39. So Learning Goal 38 and 39 says, I will be able to write ratios and use them to compare quantities, and I will be able to identify equivalent ratios using different methods and with different units. So let's go ahead and take a look at what that would look like. Your vocabulary today is ratio and equivalent ratios. Ratios are just when you compare two items. And then equivalent obviously means ones that are equal to each other. Now there's three ways to write a ratio. So let's go ahead and notice that they want us to write the ratio boys to girls. Okay, so I just identified and said we have 10 boys, 15 girls. Now, order matters. So the fact that they say boy to girls, you have to write it in that way. So a ratio can be written 10 to 15, but it has to match boys to girls in that order. We can also write 10 colon 15, and we can write 10 over 15, both ways that we would write a fraction. Okay, so all those are ways you can write a ratio. Also realize that they are treated like fractions, and so you can divide them and find equivalent ratios the same way you would find equivalent fractions. All right, so down below, let's take a look at just some simple examples. It says number of triangles to the number of shapes in that order. Okay, so the number of triangles, I have 2, 4, 6, 8, 9. So this is a 9 to, and then number of shapes, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have 9 to 18. I can write it 9 to 18, and I can write 9 over 18. We can also simplify that to 1/2, so you can write it like that as well. Okay, number of squares to number of circles. So we have squares are 3 to 1, 2, 3, 4, 5, 6. So this can be written 3 to 6. It can be written as a fraction, which is equal to 1/2. So we can also write this as a 1 to 2 ratio. All right, and number of circles to number of triangles. 1, 2, 3, 4, 5, 6 circles to 9 triangles. So this is a 6 to 9 ratio. Okay, can be written as with a colon in between as well. We can also write it as a fraction, 6 to 9. And we can simplify that by dividing by 3 over 3. And we have 2 thirds. Okay, so we could also write a 2 to 3 ratio. Okay, all right. And so that is some examples of how to write ratios. Let's go ahead and make some equivalent ratios, and we're going to do those in a couple different methods. So one is just creating decimals, pretty easy method. Another one is just creating equivalent fractions, which you've done plenty of times before, and then you've learned means and extremes in 6th grade as well, also called cross-multiplying sometimes. Means and streams is the more proper mathematical term. All right, so let's go ahead and take a look at these different options. Okay, so first let's go ahead and I'm going to do the fraction method. So let's go ahead and we'll write 10, the ratio of 10 to 9 as a fraction, and write it like that. Okay, and then I can go ahead and just multiply by 2 over 2, and I get 20/18. I can go ahead and multiply by 2 over 2 again, which is really my recommendation if you're making equivalent fractions. Just multiply by 2 over 2. It's the easiest thing. And so that is equivalent to 40 and 36. Okay, so 40, 36. So we have our two equivalent fractions already done and ready to go. And then we are going to compare them. And so there's a couple ways to compare fractions. One of the things we said that we could do is change them both to decimals, which in my opinion is one of the easiest ones. You can also make them equivalent by multiplying or dividing by a whole. So I can go ahead and set 20/18 next to 40/36, and then I can show my dividing by 2/2 to show that this is actually 20/18, and so they are equivalent to each other. Okay, let's go ahead and look at another example. So when we're looking at 1 to 8, I can actually just create equivalent fractions by, again, multiplying by 2/2. But you can look at it, sort of envision that it's going to be like this without writing it. So in your mind, you're sort of thinking times 2/2 like this. And so you would get 2 to 16, and then you would just times 2/2, and you would get 4 to 32. And for some reason I wrote 4. Okay, and so that's how you can do that. So we have two equivalent ratios. I can go ahead and write them as fractions. So I'll write 2/16 over here and put it equal to 4/32. So let's go ahead and look at means extremes. This is the idea that you just multiply the numerator of the one with its diagonal and the numerator of the other with its diagonal. And this works because it's basically saying I'm going to multiply by 32 on both sides and multiply, which cancels these out. And then you multiply by 16 on both sides, which cancels that out. So that's what you're doing when you're multiplying the diagonals. You can see it ends up doing 4 times 16 and 2 times 32. And it's setting them equal to each other. And if it matches that they're equal, then you know that they are equivalent fractions. If that doesn't work, then you know they were not equivalent. And so this means extremes is just the trick for that longer math work. And so you would just do 2 times 32, and you would get 64 equals, and then you have your 16 times 4, and you can get your, so 16 times 4 is 64, and you can see that they are equal to each other, okay? And you could have also cross-simplified a little bit if you wanted as well. All right, so next one, let's go ahead and look at these fractions. We can go ahead and write these as decimals and go from there. So let's see, 1/4 we know is 0.25, and that is 2/5 is 0.4, 0.4. Okay, so we've written that as a ratio that way. And then again, to create an equivalent ratio, the trick is to just multiply by 2, multiply by 2. And so we have 0.25 times 2 is 0.5, and 0.4 times 2 is going to be 0.8, and so 0.8. So there's our two equivalent fractions. Let's go ahead, or our two equivalent ratios. Let's go ahead and write them over on the side. So I have 0.25 over 0.4, and we're setting it equivalent to 0.5 and 0.8. So now what we can do is go ahead and actually do our third method for comparing ratios, which is just divide the fractions and see what the decimal is. So 0.25 divided by 0.4 gets 0.625. And 0.5 divided by 0.8. Oops, I didn't do 0.8. 0.5 divided by 0.8 equals 0.625. And so these are equivalent fractions, and there's the proof. Okay, and so we've identified that those two ratios are equivalent. All right, let's go ahead and look at equivalent ratios with different units. So it's sometimes you can leave the units different, and those are a rate. But if we want to write the ratio 2 pounds to 56 ounces as a fraction in simplest form, we can also look at how to make them the same units. Okay, and so you have to know how many ounces are in a pound, and so 1 pound equals 16 ounces. Okay, so let's go ahead and write our ratio of 2 pounds. And I'm going to write it as a fraction. Typically, I always write them as fractions. It's easier to work with because it's something we're very familiar with. And so if I have 2 pounds and each pound is 16 ounces, I can just multiply by 16. And we end up getting 32 ounces over 56 ounces. Okay, and then I can go ahead and simplify those. So you just have to figure out the greatest common factor of both, which is going to be 8. So divided by 8 over 8, which is 1 whole, and you end up with 4/7. Okay, and we have to represent that ratio as a fraction because they're telling us to. Okay, if you were to change them both into ounces, we would have 2 pounds over 56 ounces, and you would just divide the ounces by 16, and you ended up getting 2 pounds to 3.5 pounds. And then we can go ahead and multiply by 2 over 2, and you end up with 4/7 as a fraction. Okay, so you can see both are equivalent to each other. All right, and the last one, an official U.S. flag has a length to width ratio, that's the order, of 19:10. So this is length and width. The largest U.S. flag measures that by that. Is this an official U.S. flag? So the way to check for equivalency is to set them equal to each other. And so again, the best way is to set things up as a fraction. So we have 19/10 is equivalent to 505 over 255. Okay, and so we want to see if these are equivalent. You also have to make sure that you're putting the length and width in the same order with each other, and that's really important too. All right, so we have a couple methods. We could just turn them into decimals, which again, in my opinion, is one of the easiest to see. So 19 divided by 10 is 1.9, and 505 divided by 255 is 1.98, and it goes on to a lot of other numbers. Okay, and so these are not equal to each other. Okay, I could have also done means and extremes and just multiplied the diagonals to determine if they would be equal to each other, which they would not be. We already know. Okay, and so you can see 19 times 255 would be 4,845, and 10 times 505 is 5050, which are not equal. So no matter what method we use to check for equivalency, it is not going to work. All right, there you go.